students. See, the Nernst equation discussion is going on. The Nernst equation derivation we completed in the last class. So for the entire cell, Nernst equation I given already. Entire cell means oxidation half cell, reduction half cell, salt bridge, cathode and anode and cathode, and these two are connected externally like this. And this is the entire cell. For the entire cell, Nernst equation is E of the cell is equal to E naught of the cell minus 0.059 by n log of for the overall reaction whatever comes, overall reaction प्रोडक्ट में जो आयन्स मिलेगा वो आयन्स concentration by reactant ion concentration means concentration of product ion by concentration of reactant ion. Zinc and copper, if you take, zinc ion will come on product side, so zinc ions by copper ions. This is we are taking in the galvanic cells. This is a Nernst equation for entire whole cell. They may ask only for single electrode के लिए, means only for single metal electrodes or non-metal electrodes, means half cell के लिए, means if a metal dipped in its ions, then we can write the Nernst equation also. See how it is. Now in that case for metal के लिए, so if the single electrode metals को दे दिया तो for metals E of the metal means M plus 2 oblique plus M plus 2 oblique plus means plus 2 ions are converted to M, means reduction reaction. This is equal to E naught of M plus 2 oblique M. If it is divalent, plus 2 I am taking. If it is single monovalent, plus 1 we can write. So that's why I am writing here general form plus N. Here also general form plus N I am writing. Means N can be anything, 1, 2, 3 like that, depends on the metal valency. So here also I am taking reduction potential value only, because in table number 3.1 they given reduction potential values only. That's why I am giving all the formulas based on reduction potential values only. That's why the M plus N becomes N. M means reduction is equal to standard potential of the reduction reaction plus 0.0591 by N log of this M plus N molar concentration only, that's all. Means when metal ion undergo reduction, these metal ions molar concentration only you need to write, that's all. Here plus we need to write, this is you need to get the answer now. So this is for metal atoms. For metals formula is this. So if single electrode, if metal is given, this is the way of applying the Nernst equation. So application only for this entire cell, application only I am writing. So M plus N becomes M, means reduction potential value of the E is equal to its standard reduction potential value plus 0.059 by N. N means number of electron transferred plus into log of these metal ions concentration. This is for what? Metals के लिए. And now for the non-metals, what will be the formula? This is for entire cell के लिए formula है. This is for metals के लिए. Now if any non-metal is given, any non-metal, for the non-metal also reduction potential value only I will give. See the E of non-metal. Non-metal, let us take A. A is the non-metal. A plus N becomes A. A is the non-metal, M is the metal. So is equal to E naught of A plus N oblique A minus 0.0591 by N log of this A. Actually non-metals gains electrons. That's why it should not plus n there, it should be minus n. So here also what happened? Minus n. So reduction potential value only. It means you need to write A becomes A minus n. Here also A becomes A minus n. Reduction potential value. So here non-metals always gains the electrons. So A become A minus n. A become A minus n. So this is normal potential, this is standard potential of the non-metal. Minus 0.05 by n log of A minus n concentration. This is for non-metals के लिए formula है. See, metals and non-metals का difference you see once. For the metals you will get the positive sign there. For the non-metals you will get the negative sign. That is only the difference, that's all. For metals positive sign, for the non-metals negative sign will come in between. That is only the change, that's all. Everything is same only. So if metal ions concentration is given, we can substitute there, this value they will give, and electrode potential of that metal electrode we can find out. For non-metal electrode, this is the formula, minus only will get. For the entire cell, formula is this. So in numericals mein these formulas we can use. And these applications of these electrochemical cells are all there. Applications of electrochemical cells mean, see, number one, see, means very important one is concentration cells. A very important concept for the objective के लिए concentration cells. This is nothing but the electrochemical cells only, but Daniel cell galvanic cell जैसा होगा, but ये something some point में different हो जाएगा. So I will give these concentration cells means what? This is exclusively for the objective के लिए. It is not given in NCERT, completely objective concept it is. What are these concentration cells? I will tell you first. See, so here also two half cells are present. Two half cells. In this one electrolyte we need to place one electrolyte. Here also one electrolyte we have to place one electrolyte. What I am taking is, here the very important thing. Here I am taking aqueous zinc sulfate. Here also I am taking aqueous zinc sulfate. See, the same aqueous solutions I am taking, but concentrations of the concentrations of both aqueous solutions are different I am taking. For example, its concentration I am taking generalized करके C1 I am taking, its concentration C2 I am taking. Here the rod, here aqueous zinc sulfate is taken means, so we need to take here aqueous zinc rod, means zinc rod only here. Here also we have to take the zinc rod only, because to pass the electricity, whatever the rod is taken, that rod must be dipped in its ions. In both the vessels we are taking the zinc sulfate solution only, that's why zinc rod only we need to take. These are called concentration cells, means the cells in which the same electrodes are dipped in its aqueous solutions of different concentrations are called concentration cells. Means the two half cells are having same electrodes, zinc and zinc, here also zinc, here also zinc. Same electrodes are dipped in its ions of different concentrations. So these are called concentration cells. Concentrations are different, that's why they are called concentration cells both. So this is common, the salt bridge is present, this is as it is. Salt bridge is present and these are connected through external source like this, and here ammeter is there. This is as it is, this construction is as it is. But same electrodes are taken, different concentrations are taken. Now from where to where the current is passing generally? Generally some when low concentration to high concentration current is passing generally. And here also some cases are there. I will give, first of all, listen this concepts carefully. So this is concentration cell I am taking. See, what I am taking is, now I am going to write in the reactions are taking place at respective electrodes. So we already know in the left hand side always oxidation reaction takes place, in the right hand side reduction reaction takes place. So this is acting as anode, we know, and this is acting as cathode. Here anode and cathode both are the zinc rods. Same electrodes only should be taken in the concentration cells. So the reaction taking place at anode are, see, zinc solid. Here zinc rod undergo oxidation. It forms Zn2 plus aqueous and releases 2 electrons. Here, for example, zinc I am taking, zinc and zinc aqueous solutions. Here also zinc rod, zinc aqueous solutions. Anything you can take, but same electrodes in its same aqueous solutions, but different concentrations. Then they are called concentration cells. So this is going on at anode. Now the reaction takes in place at cathode. How much? At cathode, whatever the zinc ions are there in the vessel, the zinc ions gains these 2 electrons. It forms zinc solid. It forms their zinc solid. So what will be its overall reaction? This overall reaction I will write it in here gap is not there. I am writing here its overall reaction. See what happened. Its overall reaction is the 2 electrons cancelled. But see, overall reaction is the zinc solid plus Zn2 plus aqueous solution of what is the concentration? This Zn2 plus ions are present in the right hand side. Its concentration is how much? C2. So this is C2 I am writing. Gives. Now you will get here Zn2 plus aqueous again. Zn2 plus and aqueous. It is present in its left hand side. Its concentration I have taken as C1 there. So this is C1 plus this will be zinc solid only. That's all. This is the overall reaction. Of course, the zinc solid will get cancelled. So overall reaction I am showing here. For this different reactions, overall reactions only I am showing here. Suppose here one thing we have to understand. The standard EMF of the cell kitna hai? Overall EMF of the cell we will find out. Overall kitna current pass ho rahi hai we will find out by using Nernst equation. But for the Nernst equation E naught value also you have to know. How much is the E naught value of this cell? For example, see here what happened. Zinc is losing 2 electrons with respect to these electrons. Actually what is this? It's a undergo oxidation there. Oxidation. So oxidation potential kya hoga? See, here in this case zinc undergo oxidation there. So I am representing this reaction, I am representing as the standard oxidation potential. It is undergo oxidation. So standard oxidation potential means E naught of zinc solid becomes Zn2 plus aqueous. This is only going on here. Zinc solid becomes Zn2 plus aqueous. This is only going on. For example, this is if I am taking as X. We don't know how much it is. Let us consider X volts are coming out. E naught value is X. Now this is undergo reduction there. Let us take the standard reduction potential of this. SRP means E naught of the reduction potential. Means Zn2 plus becomes Zn. See, Zn2 plus becomes Zn solid. Its value how much? If इसका reverse reaction only, no, this one. देखो, इसका reverse reaction only this one. If you consider its value is X, then its value will be how much? Minus X volts होगा. minus x volts. I have taken standard oxidation potential and standard reduction potential. Now standard EMF of the cell, how to find out now? See, the standard EMF of the cell, E naught of the cell. If you know SOP and SRP, I given one formula, I given three formulas. If only SRP values are taken one formula, only SOP values are taken another formula, one SRP, one SOP ले लिया तो the formula is standard oxidation potential plus standard reduction potential, means its value means what? E naught of the zinc solid gives Zn2 plus aqueous oxidation potential plus E naught of reduction potential means Zn2 plus oblique Zn. So kitna hoga? Its value is x, we got it. This is minus x, therefore 0 volts. So for the concentration cells, standard EMF of the cell 0 volts hoga. The standard EMF of the cell, you will get 0 volts for the concentration cells, because same reactions only going on oppositely. So if it is x volts, means this will be minus x volts. So sum of these two potentials will be, you will get 0 only. So for the concentration cells, standard EMF of the cell will be 0 volts only. Now let us apply the Nernst equation for this. See, this is overall reaction we know. For this overall reaction, let us write the Nernst equation. See what happened. The Nernst equation we already know. So EMF of the cell is equal to E naught of the cell minus 0.0, this is overall cell के लिए 0.0591 by n. So log of, see in this overall reaction, product ion concentration how much? The product ion concentration how much? C1. Directly I am substituting now C1. So C1 by reactant, this is solid, we cannot write, this is also solid, we cannot write. Now this will be C2 hoga. So concentration of C1 and concentrations only, no, directly write concentration of Zn2 plus by Zn2 plus, but this Zn2 plus concentration C1 by this will be C2 hoga. How much is the n value? How many electron transfer? See, zinc loses 2 electrons, Zn2 plus gains 2 electrons, so n should be 2. Substitute E naught of this cell, how much we got it just now? 0. Substitute now. So E of this cell is equal to, this will be 0, this will be 0 minus 0.0591 by n how much? 2 into log of C1 minus C2 hoga. C1 minus C2. So it is nothing but E of the cell is equal to minus 0.0591 by 2 log of C1 by C2 hoga. This is the final equation for this cell. If cell changes, if these electrodes and the concentrations are changes, yeah, this number also may changes. This is for zinc area, we got this one. Actually, this equation we can use for the one type of objective reactions, that what they will give is which of the following is feasible, which of the following is not feasible. This type of questions they will give. Which of the following is feasible, which of the following is not feasible, ऐसा questions पूछता है concentration cells में. Means what they will give is the C1, C2 values, they will change it. How they will give, I will give all the cases. Now I am taking this one as, see, case 1 I am taking, see. Case 1, how they will give the questions. See, case 1 I am giving the questions. See, number 1, if C1 equal to C2, if both concentrations are same, Is this reaction possible or not? You have to find out. So, if concentrations of both the zinc sulfate vessels are same, what happens? See, in this reaction, C1, C2 are same. Same means it will be cancelled. So log 1 will be 0. So this entire value will be 0. If this entire value is 0 means E of the cell, what happened? Then E of cell will be 0. E of the cell is 0. So the reaction is feasible or not? The reaction is feasible or not? How to get it is by using delta G value. डेल्टा जी वैल्यूज करने से हम लोगों का आ जाएगा reaction feasible or not, or reaction spontaneous or non-spontaneous. Questions also they will ask it. See, spontaneous, non-spontaneous reactions also they will ask. See, E naught value 0 आ गया. E naught value 0 means no current flow is going on. No current flowing is going on means no any reaction is possible, means it is not feasible. And one more thing also, see, we have the formula delta G equal to minus NF E of the cell. This is, we have one formula, delta G equal to minus NF E of the cell. So here E of the cell we got 0. If it is 0, delta G value how much you get it? 0. Delta G 0 means it is actually not possible. If delta G is negative, if delta G is positive, spontaneous, non-spontaneous we can take. Here delta G equal to 0 means it is in the equilibrium. It is in the equilibrium. If the reaction, if it is equilibrium reaction or not, if they ask delta G 0 means it is showing that yes, it is in the equilibrium reaction. Current flowing is nothing. Current flowing is 0 there, nothing, no current flowing is going on there. And now, see another type of questions. See case 2. Case 2, see what happens is, if C1 greater than C2, if concentrations of C1 greater than C2, see what happens. If this value is greater than this one, so what happens? A log value you will get positive value. Suppose C1 is 100 and C2 is 1, or C1 कितना होगा? C1 is 10 ले लो, C1 by C2, C1 10 ले लो और C2 1 ले लो, कितना होगा? 10 होगा. So a log 10 value 1 मिलेगा, log 10 value 1. So this entire value आपको negative आ जाएगा, because this negative sign, this entire value आपको negative आ जाएगा. Means E of the cell negative आ रही है, electrode potential negative आ रही है. Zero potential is not possible. No, electricity potential means always positive sign. Yet is 0 is not possible there. 0 is not possible. No current producing, no current flowing is going on. So here what we are getting is, if C1 greater than C2 means, in this case E of the cell we are getting negative. E of the cell is negative means apply this formula. The E of the cell is negative. Negative of negative positive hoga. Then delta G how much now? Therefore delta G will be positive. We know delta G positive means what? Non-spontaneous. Means it is not at all feasible. Because 0 potential means no current flowing. Negative potential is not at all possible. No. That's why delta Z positive means it is non-spontaneous. Non-spontaneous and it is not feasible also. ऐसा questions पूछता है, if C1 greater than C2 what happens? Is it spontaneous or non-spontaneous? Is it feasible or not feasible? ऐसा questions पूछता है. If C1 greater than C2, it is not feasible. Then case 3. See case 3, if C1 less than C2, if C1 less than C2. If it is less than this one, this entire value you will get the negative sign. So negative of negative you will get positive. So E of the cell we are getting positive. Then it is possible. It is possible now. Why? E of the cell is positive means delta G will be negative hoga. So therefore delta G will be negative. Delta G negative means we know it is spontaneous. So therefore it is spontaneous means it is possible. So concentration cell में electricity generating and reaction possibility के लिए the C1 should be less than C2 means C2 should be greater means the right hand side cathode ka aqueous solution concentration should be greater than this. It means what I said in the beginning of the video, always current, always electricity flow hoga, electrons flow hoga from the low concentration to high concentration. Left hand side C1 I have taken, right hand side C2 I have taken. Left hand side C1 should be lesser to C2 is greater means electrons are flowing from C1 to C2 means left hand side to right hand side. Current flowing from high concentration to low concentration. This is going on. Please make it note down here. Current is flowing from C2 to C1 means left hand side to right hand side, but electrons are flowing from C1 to C2, left to right. This is going on in concentration cells. If it is feasible or not feasible, ऐसा questions पूछता है. So like this way you need to get the concentration cells ka concepts here. So after this concentration cells, what we can write it is, see, after the concentration cells, we have some relations also. We have some relations. See, now the relation between K equilibrium constant Kc and delta Z naught. Relation between Kc and delta Z naught means standard Gibbs energy. Standard Gibbs energy and equilibrium constant बोल के one relation is there. What is that relation? I will derive it now. So we have one formula, no? Delta Z equal to delta Z naught plus RT ln Kc बोल के one formula है. Next equation derivation में भी ये formula दे दिया, but just I proven it at equilibrium the delta Z value is 0 because we want equilibrium constant means the reaction, any reaction जो भी ले लो, the equilibrium reaction लेना है. At equilibrium delta Z value 0. If delta Z 0, this equation is changes to delta Z not equal to ये इससे आ जाएगा minus RT ln Kc होगा, minus RT ln Kc. This is I am taking as equation number 1. So this ln I am changing into tangent logarithm. This is natural logarithm to the base e मिलेगा. Now tangent logarithm what will we get? Delta Z naught equal to 2.303 से multiply करना है. So minus 2.303 RT log of Kc, it is now to the base 10. Here we are getting in base 10 now. This is equation number 2. Equation number 2. And we have one more formula also. See, the standard Gibbs energy change is equal to minus NF E naught of the cell also there. This is in terms of standard states. Delta G naught means standard. So you should take here E naught standard state. Normal states also we can take delta Z and minus NF E. Normal states also we can take. So this is I am taking as equation number 3. Now what I am doing is I want the relation between Kc and delta Z naught. We got it. Delta Z naught and Kc. And one more relation. Kc and E naught of the cell also. Relations between all these three also, let us do it now. We got first two relations, means Kc and delta G naught value is this one, these two. Now Kc and E naught value, the relation also I am deriving now. How? Equate 2 and 3 now. 2 and 3 equate, delta G and delta G naught is equal to 0. So if you add these two, what will we get? Equate these two. Now equate 2 and 3. Equating 2 and 3, what will we get? Is minus NF E naught of the cell is equal to minus 2.303 RT log Kc to the base 10. Always no need to write the base 10. LOG means base 10. Ln means base E. That's it. So minus minus is cancelled. Therefore, E naught of the cell is equal to 2.303 RT by NF of log Kc. NF of log Kc. Here over here. Next we have some constant 2.303 RT are all F also constant. N is varies now. If we substitute all these constant values, so you will get, see, E naught of the cell is equal to 0.0591 by N log of Kc. See this relation. It is equation number 4. It is the direct relation between standard EMF of the cell and Kc. If standard EMF of the cell is given, equilibrium constant Kc you can find out. Suppose if they are aqueous solutions Kc, suppose if the gases are any given, if gases are given, you can write here Kp also. You can write Kp. So like this way you can give this relations between the Kc and E naught of the cell. So N we have to know from the equation how many electrons lost, how many electrons gained. So these are all the important relations which are useful in the numericals. Next one, next equation I given for aqueous solutions. Aqueous solutions ka formulas. See, मैंने cell notation I am giving now. I am giving some cell notation. Cell notation means suppose see galvanic cell, zinc oblique Zn2 plus, zinc oblique Zn2 plus aqueous solution, salt bridge. Then suppose the Cu2 plus aqueous solution becomes Cu solid, Zn solid. This is cell notation. लेफ्ट हैंड साइड ये ऑक्सीडेशन होगा, राइट हैंड साइड रिडक्शन होगा. फॉर दिस नेक्स्ट इक्वेशन हाउ वी आर राइटिंग इज E of the cell is equal to E naught of the cell minus 0.059 by N log of product ion concentration by reactant ion concentration. No? So how do you write? You need to form the individual reactions so that overall reaction will come. Overall reaction में product ion by reactant ion we can write, but without writing the overall reaction means what? For this overall reaction means what? Zinc, because zinc becomes Zn2 plus 2 electrons, and here Cu2 plus gains these 2 electrons, it forms copper. Overall reaction adding them this plus this equal to this plus this होगा. अभी प्रोडक्ट में आयन क्या है? Zn2 प्लस. प्रोडक्ट में आयन आपको Zn2 प्लस आयन बाई रिएक्टेंट में आयन is Cu2 प्लस आयन आएगा. So if the notation is given, so which ion will come in product side, which ion will come in the reactant side, ये आने के लिए individual reactions लिख के overall reaction लिख के, overall reaction में product ion by reactant ion we have to write. But without writing that, easily we can write it now. Left hand side में जो ions है वो product में आना चाहिए, ऊपर में आना चाहिए. Right hand side में जो ions है वो नीचे आना चाहिए. Why? It is undergo oxidation. So A reactant में होगा, A product में होगा. ये रिएक्टेंट में होगा, ये प्रोडक्ट में होगा. इसमें से भी ये रिएक्टेंट में होगा, ये प्रोडक्ट में होगा. सो प्रोडक्ट बाय रिएक्टेंट ऐसा होगा. प्रोडक्ट बाय रिएक्ट मीन्स दिस बाय दिस डायरेक्टली वी कैन राइट. Without writing these individual equations, we can write. This is one point. Next point. Here, all our aqueous solutions are given. In some cases, some gases also they will give. Some gases also they will give. See how the gases. I will tell you now. Suppose the same thing. Zinc solid becomes Zn2 plus ion aqueous solution. Becomes, see the 2H plus ions becomes H2. 2H plus ion, right? H plus oblique H2. Here H plus aqueous solution, H2 is a gas. It means what? Here zinc undergo oxidation, here H plus undergo reduction. So how do you write the next equation for this? See what I am writing? Applying directly. E of the cell is equal to E naught of the cell minus 0.059 by N. N you will get 2 electrons only. N will be 2 only. So log of, now tell me. Log of, tell me in the product side what will we get? Obviously this one only. Product side this one only will come. Just I told you. So Zn2 plus ion molar concentration by what will you write? See what I am writing? By H plus ion molar concentration square. Square I am writing into partial pressure of H2 I am writing because it's a gas. Gases has some pressure also. These pressure values also you have to mention because in the equilibrium constant, if they are gases, those values also you need to write no in the equilibrium constant expression. So if the gases are given, the gases pressure also they may give. मैक्सिमम वो प्रेशर 1 atmosphere भी देता है. So its value will be 1 होगा. If other than 1 atmosphere is given, those pressure value also you need to write there. The pressure value also you need to write. But is it right or wrong? But here H plus square क्यों आ गया? H plus square क्यों आ गया? ये प्रेशर नीचे आ जाएगा, प्रेशर ऑफ H2 नीचे आएगा, ऊपर आएगा. Let us check, is it right or wrong? क्रॉस चेक करेंगे. मैंने तो ऐसा दे दिया. Let us cross check. So क्रॉस चेक आने के लिए ये पूरा individual reactions लिखना चाहिए. If gases are given, means non-metals like hydrogen are given, how to write? ये square क्यों आ गया? I'll tell you. मैंने तो नीचे लिख दिया. Is it right or wrong? Let us check. I don't know. I have to check this one. So let us check. To check this one, इसका individual reactions लिखेंगे. So at anode, zinc loses 2 electrons, it forms 2 plus like this. So here H plus become H2, means H plus ions become H2. How? H plus ions gains. How many electrons are coming there? So 2 electrons compulsory. The number of electrons lost should be equal to number of electrons gained. Here 2 electrons are lost from 1 mole of zinc. So those 2 electrons has to gain. But H plus required only 1 electron. But here 2 electrons are coming means compulsory 2 moles of H plus ion should be taken. Then you will get H2 gas there. H2 gas. Now this is aqueous solution. This is solid. And this one is aqueous solution. Now see the overall reaction. Overall reaction is what? Zinc solid plus 2H plus ions aqueous. The 2 electrons cancel, gives. So you will get Zn2 plus ion aqueous plus H2 gas. H2 gas. Now you can get an idea which one should write here. See here, E of the cell, okay. E naught of the cell, okay. minus 0.05 n by n. Here 2 electrons are transferred, n equal to, so the log of productive ion Zn2 plus is right, but H2 gas is comes in the product side only. हम लोग नीचे लिख दिया, so ये wrong हो जाएगा. So what will you write now? So Zn2 plus ion, see once again I am writing now. Product में ion क्या होगा? Zn2 plus ion concentration into the partial pressure of H2 also there, because gases also we need to write in the equilibrium constants, but the pressure, so divided by a solid we cannot write. Here aqueous ion we have to write how the concentration of H plus ion, whatever the coefficient is there, वो coefficient आपको power में जाएगा. So H plus ion square. So this is the way of writing Nernst equation. If any gases or any some moles में multiply करने से you will get these values there. So whatever the coefficients are coming, वो coefficients power में लिखेगा, so active masses हो जाएगा. This is actually we are writing in the equilibrium chapter also like this way. So in exam Zn2 plus ion concentration they will give, partial pressure of H2 also they will give some atmospheres like that. Usually they will give 1 atmosphere. If other than atmosphere anything is given, you have to substitute there. And H plus ion concentration also they will give. So all these you need to substitute, you will get this log value, and n value you will get from this equation as 2. E naught value they will give. If it's not given, we know the formula na? E naught of cathode minus E naught of anode. If both are SRP values are given, then the E of the cell you will get it. So like this way the Nernst equation you have to apply if any cell notation or any overall cell is given with different concentrations. So like this way the Nernst equation problems you can do. So in the next class I will give the Nernst equation numericals and Faraday's last numericals also pending hai. So we will do these numericals in the next class. So that's all today. So Nernst equation tak ho gaya. Thank you.